Good morning. We are just waiting Dr. Kyung Nam. So he was supposed to come here from ADB. Just we'll wait 1-2 more minutes and then we can start. Today is a bit not the best day because the Manila is like today is holiday in Manila, and also the Friday, the last day of the conference. So that also might might be the reason why not so many people joining, but we will start very soon in 2-3 minutes maximum. Just I'm waiting whether Dr. Nam is on the way. I just send a message to him, so we'll just check. So will not take that long, just maximum 2-3 minutes. Okay, it's already 9:05, so now we need to start. Good morning. Once again, I am Narayan Chaulagai, represent GIZ Nepal, and also the task force lead for organizing this session together with ADB. Distinguished delegates and guests, dear speakers and participants, ladies and gentlemen, very good morning. First of all, I, on behalf of GIZ and Deep Dive Workshop Session Organizing Team, I would like to express our sincere thanks to ADB and SF organizing team for providing us this opportunity to organize this session. That's co-organizing this session together with ADB. Thanks to all speakers and the organization they represent for accepting our request to partner with us in contributing to this session. Thanks to all of you in the audience for coming to our session today, because today is not the best day. That I already told you that the last day, many of you already tired and also ready to fly back to your home countries. So anyway, we're really grateful that you are here still today. A warm welcome to all of you from the organizing team. The main objective of our session today is to bring real stories from the ground on how digital innovations are playing a great role in just energy transition through different tools, methods, technologies in different countries in the Asia and Pacific. Now let me allow you to remind you about some of the theoretical aspects of our session title. The digital innovation for just energy transition. That's the title that our session is given. A digital innovation, it's about using transformative power of digital tools to create value, to solve problems, to drive improvement across various sectors of our life. Digital innovation leads to competitive advantage for businesses to stay resilient in dynamic markets, to disruptive opportunities for new ways of doing business, increase flexibility for real-time data-driven insights to make informed decisions quickly. Digital innovations are not just tools for efficiency, they are the promoters of inclusion and equity in the energy transition. Digital solutions help liberalize and democratize energy services and energy solutions that ensures no community is marginalized in the transition process to a sustainable energy future. Digitalization provides access to more granular and real-time data, which is essential for informed decision-making, policy formulation, and tracking progress towards energy transition goals. Digital innovation is not just a technological advancement, but it is a critical tool to achieve a fast, efficient, and most importantly, equitable energy transition that benefits, achieve a fast, efficient, and most importantly, equitable energy transition that benefits all of humanity. Now let me talk a bit what is just energy transition. Just energy transition refers to the global shift from traditional and fossil fuels to clean, renewable, and efficient energy solutions while addressing the social, economic, and environmental impacts on communities, peoples, and regions relying on traditional and fossil fuels. A just energy transition is not only a technological change that I already told you, but a profound societal transformation which is fair, democratic, and leaves no one behind in this transition. And also the transformation is fair and leaves no one behind in this transition. A just energy transition cannot be realized without smart technologies like smart grids, data-driven insights, and digital platforms empowering local communities and promoting energy fairness and energy justice. The digital innovation offers a great opportunity to redefine our relationship with energy transition, making it not just clean, but also accessible, affordable, fair, and sustainable. Digital solutions can bridge the gap between energy surplus and energy poverty, but only if they are built with a deep commitment to equity, justice, and human well-being. Digital technologies can facilitate the just energy transition in several key ways. Like digital solutions democratize energy access and ownership. Digital solutions optimize energy system and grid management through smart grids, data-driven decision-making, and AI-powered visualization. Digital technologies accelerate delivery and reduces cost through efficient project management, optimizing processes, preventing waste, and enabling better cost control. Open source technologies. Digital tools enhance resilience to mitigate and adapt to climate change. Digital technologies foster innovation and inclusion. Digital innovation creates an enabling environment for green energy adoption by unlocking economic opportunities, de-risking investment, and developing market capacities. Digital solutions can contribute to addressing gender equality, social inclusion challenges within the energy sector, ensuring a more diverse and equitable workforce. Digital platforms facilitate exchange of information, skills, and expertise, accelerating innovation and making clean energy solutions more accessible to developing countries and marginalized communities. Despite the number of benefits that I have outlined, implementing digital innovation for a just energy transition presents a complex set of challenges. It's not that easy and simple. Like the social and equity challenges, technological and infrastructure challenges, economic and financial challenges, regulatory and governance challenges. Overcoming these challenges requires a holistic and collaborative approach. Sometimes we also would like to call it system approach, involving governments, industries, academia, civil society, and local communities. It necessitates proactive policy making, strategic investment, capacity building, and a strong commitment to equity and inclusion. With this note, now I would like, we are expecting Dr. Ki Young Nam, maybe he's still coming or he could not join. So anyway, that something happened. But anyway, now I would like to invite the first speakers of our session, Ms. Amy Aditi Pramita Saris. She is Energy Advisor for Solar Cooking Project at GIZ Indonesia. She will talk on towards a just energy transition, empowering island fishery communities through smart solar-powered ice production. Now, Ms. Amy, the floor is yours.
Oh, okay. You can use your ones or yes. Okay, thank you. Okay, yeah. Good morning, everyone. I'm Amy Aditya. I'm from GIZ Indonesia, and I'm here as advisor and for the Solar Cold Chain for Green Economy or SOCOL project. I'm here, our mission, expand the application of solar ice maker. And I would like to highlight the connection between the energy access and the fishery sector. So we realize that over 1 million people still have lacking access to electricity, and most of the location have the problem about the fish losses. And in the context of Indonesia, Indonesia is the first archipelagic country with many islands, and it makes us as the largest second fish producer in the globally. But most likely, the 90% is small-scale fisher that living in the many area of eastern of Indonesia. And fisheries in Indonesia is the main sector to contribute the national economy, but still have problem in the annual fish losses and limited access to the cold chain because unreliable electricity to access the cold chain facility. And this is the challenges as well. So, for example, this is the tuna, yellowfin tuna, and this is high price as well as the fish. And we found in the eastern of Indonesia is Maluku. And the price is high, so we should maintain the quality of the fish. Meaning that we require ice block to maintain the quality. And this is our bring solution to direct to the island community. So we bring the technology solar ice maker by integrating the solar PV, the cooling application like the ice making machine to produce 1.2 ice production every day. And this is the technology actually, and there are three main systems here. This is the solar PV, including the battery, and also the inverter as well. And the second is the cooling system, that compressor, refrigeration to produce the ice. And also the main is the control system to digital input and everything. And here the highlight of the feature of the solar ice maker, there are three. The first is 100% is full of grid and dynamic operation, so following the irradiation of the sun. And the second is more efficient because not using the big battery, but we combine with energy thermal storage. And this is some of the smartest solar ice maker because they can operate in dual mode, automatically and manually. And also because they can digital relevant input like the solar irradiation, temperature, and water flow to operate the solar ice maker machine. And this is also the technology is equipped with the real-time monitoring system, so it's easy for the operator to know, to observe about the system from the PV, from the cooling, the battery performance as well, and the production of the ice block. So the operator know when the ice still producing and ice is ready to harvest. And this is the performance of solar ice maker. We can focus on the green line and yellow line. Green line is the PV generation, as I mentioned before, because the intermittency of the solar, so they provide the intermittency of the solar generation. And the yellow line is the compressor or the load for the cooling system. And this is the container of the solar ice maker. Actually, this is the second version of the solar ice maker. We make it the new design because most of the location of the solar ice maker is remote area. So the container design is suitable to install and also to mobilize to the island. And I realized that sustainability is also important. To make sure that operator or user know about the system, we provide the technical hands-on experience. So the operator know how to operate the system, how to maintain the system as well, and make a troubleshooting. And this is actually the concept from solar ice maker until the project implementation. So we start in 2014 by the concept, and then we make it the engineering prototype, testing, and the first solar ice maker is installed in 2022, and then we continue, and last year we installed the second solar ice maker. This is the second solar ice maker, and this year, actually, we received our outstanding project from the Intersolar Global Award as the outstanding project in Germany, and this is like our proven technology and can be impactful to the community island. And this is our achievement so far. So this technology already implemented in the 2 locations, most likely in Eastern Indonesia, and manufacture and production in Indonesia as well. And this is adaptable technology for the island context. So the first solar ice maker in Kupang and the second in Maluku. So this is our features. So benefit our system in 1 year. So it creates the local value at least 80,000 USD by selling the ice and selling the fish. And it can mitigate 80 tons of CO2 emission as well. And we are not working alone. We're working together with the technology refrigeration company, solar PV company, and also the international applied research. And to make more big impact, we're working together with the Sustainable Fisheries Organization. And, and this is collaboration is important to us. And this is for the future, so we realize this technology is more adaptable and suitable for the local island. So I would like to address that this technology, it helps very small fisher to maintain their income by maintain the fish quality and get price. And so to conclude my presentation and sharing here, let's working together to make the sustainable cooling access for the island by adopting the ice maker, solar ice maker. So I'm happy sharing with you about the story of solar ice maker from Indonesia. And this is the last of, previously is the last of the publication. You can scan the publication. Okay, thank you very much. Good morning, everyone.
Yeah, thank you, Amy. A really, really good one. And also congratulations for getting the Intersolar Award. Really innovative and groundbreaking the impact that your project, your technology bringing in. So thank you very much. So maybe you have noticed that the format of our presentation, it's a bit different. We do not have the mouse click. It's the transition happening automatically, 20 by 20. It's called Pecha Kucha. Maybe you can also Google it, and it's very last in 2023. Also, we were the only one in SF organizing the session in that format, and we liked very much, and we also got positive feedback, and then we decided this year why not to continue in the same way. So when not many of others doing, so why not? So it's really easy to handle with the timing and also, but it's something that you'll be noticing further also. Then we'll have more Pecha Kucha. It's just to bring you notice that if anyone not familiar with Pecha Kucha. So anyway, thank you once again. So the second one, I would like to invite Mr. Maximilian Heil, Project Coordinator GIZ Thailand, to talk on From Data to Decisions, CPET and the Power Policy Tracker for Smarter Transition. Max, the floor is yours, please.
Okay, so I also have to be quick. Hello again, I'm Maximilian Heil from GIZ Thailand, and today I will share about CPAT, the Southeast Asia Information Platform for the Energy Transition, which is developed under the project GIZ. It's helping connect people and data to accelerate a just and smart energy transition across the region. I speak on behalf of GIZ, Clean, Affordable and Secure Energy for Southeast Asia. This is a regional project that's funded by the International Climate Initiative of the German government. We work across Indonesia, the Philippines, Thailand and Vietnam to support an evidence-based, inclusive energy transition. And we implement in a consortium with partners from Germany, like New Climate Institute and Agora Energiewende. And we also have partners in the region, such as ERI, TDRI, ISR, and ICSC. Together, we create knowledge and help shape enabling conditions for a clean and secure energy future. So, what's the mission of GIZ? GIZ aims to support Southeast Asia's path to carbon neutrality while maintaining energy security and affordability. We do this by strengthening evidence, building narratives, and supporting strategic dialogue. Our work spans across 5 areas: producing research and evidence, engaging non-energy stakeholders, providing technical assistance, and promoting public discourse, as well as transparency and mapping. Today, I will focus on the last area, which is transparency and mapping. So, in 2020, we did some market research. We interviewed stakeholders from the region, and we found one major gap. There was no shared platform connecting energy data with people. This led to the creation of CPAT, with the long-term goal of handing it over to a regional host for sustained use of this platform after the project. So what is CPAD? CPAD is an interactive open access platform designed to strengthen energy transition through transparency and regional coordination. It connects data, policy, and people across Southeast Asia. The platform helps users to understand transition challenges, identify entry points, and learn from each other. CPAD's goal is not just to inform, but to empower decision makers and practitioners. So as you can see here, CPAD has three core features: a knowledge hub with up-to-date data insights, a project mapping tool where you can see who's doing what, and the power sector resources, which are tools tracking the transition across the region. Now I would like to focus on our project mapping tool, which is a database of energy projects of development partners in the 4 countries, Vietnam, Indonesia, the Philippines, and Thailand. And any donor organization can become a member and upload their energy project here. It's very transparent and easy to use. You can filter by donor. You can even find contact details of people who are implementing the projects. And it's really good to kickstart new collaborations. Currently, we have 481 energy projects listed on the tool, and that represents a budget of and investment of over $45 billion US. And this represents the 4 major South Asian economies. And I think this is just a great overview of where the money and the momentum go. Looking at the data, we see that most of these projects, which are listed on our platform, are in the JET-P countries, Vietnam and Indonesia, just followed by regional projects and projects in the Philippines and Thailand. So we also have the power sector resources, and they consist of 5 tools where we share data insights on the energy transition. For example, on energy generation, consumption, and emissions. And yeah, you counted right. 1 tool is missing because we are launching it today. That's the Power Policy Tracker. This is our newest feature. It's a structured comparative overview of energy transition policies across all ASEAN member states. And the tracker covers renewable energy targets. You can look into the grid plans and also into EV policies for 2-wheeler and 4-wheelers. It's linked directly to national policies and regulations, and it enables users to trace goals to legal frameworks. We also have our own knowledge hub, where users can upload publications and access recent research. You can also sign up, and I would really like to encourage you for our newsletter, to stay up to date on the newest transition news. So now I would like to encourage you to get out your phones and scan the QR code to sign up for our newsletter and check out our new policy tracker. If you have any feedback or questions, please get in touch with me during the Q&A or just after the session. We are also currently scouting for organizations which are interested in running CPAD from mid of next year. So if this sounds interesting to you, please also get in touch. Let me take some time to thank also all the partners and contributors who, because without them, this would have not been possible to create this knowledge platform. And also the CPAD community. So I would really like to invite you all to help grow this platform into a long-term sustainable resource that empowers a fair, fast, and well-informed transition. So once again, visit cpad.org and learn more. Thank you.
Good. Thank you, and also congratulations for launching the policy tracker. Really good. That's today really the special day. That also not only for others, also for you and for everyone who could benefit from the tracker. Thank you once again. Now may I kindly invite Ms. Eunice Stone, Energy Advisor GIZ Vietnam for bringing her message on digital management of green investment project pipelines in the commercial and industrial sector and application use case. So please Eunice, the floor is yours.
Good morning, everyone. My name is Eunice, Energy Advisor for GIZ. It's a pleasure today for me to introduce you to our project development platform. This is a powerful tool that we use to manage a pipeline of 2,000 green investment projects in across 25 countries. At the project development cluster, we support green investment in commercial and industrial sector. We offer technical evaluation, technical optimization, financial analysis, and also matchmaking with the suitable partners in 4 main technologies, which is electricity supply, energy efficiency, green hydrogen, and process heat. So far, we have identified 1,009 green investment projects, which amounting to 3 billion worth of investment. And we also matching 500 local companies with the service provider. So the challenge was, let's look at how we work usually. We are a diverse team of 25 countries, 25 nationalities, 50 people, different culture, different working style, and aligning our processes was a major challenge. So coordination work took a lot of effort. We have so many questionnaires, files were saved in different locations and versions. The communication usually took through long email threads, and this made our collaboration was a nightmare. So just a little bit of how many tools we have. We have multiple Excel tools for different templates, different technology, different progress, and different activity, like financial link tool, load measurement, so on and so forth. I can keep going days and days and nights for all of these tools we have for the past 10 years. Now we are shifting to a digital platform for the now and the future. It's replaced the Excel with more efficient and collaborative system. The platform supports project development throughout our standardized 10-step process, making our work smoother and more consistent. So the benefit that we have through this platform was we streamline our process through the 10-step workflow, better collaboration through 4I's principle, and also real-time insight, which make our data analytics become more and faster through 20 countries. So for first step, we have a public link that interest partners can submit a request to us. This is like a ticketing system. And the platform also includes tools for us to perform due diligence, sanction checks, everything online. For the team on the ground, we have a mobile application that used for data collection. At the factories, our team can take photos, input measures like height, orientation of the roof, upload timely on the cloud-based platform. Let's talk about how we collaborate. The platform helps us to collaborate tasks, send alerts, chat, and better quality control among the team. External consultants also can upload results directly to our platform, and this is a seamless integration for us to progress with any investment projects. For data analytics, this platform enhances our data analysis. It tracks impact clearly, promotes accountability, and monitors indicators and goals effectively. With real-time insight and adaptable tools, it supports better decision and at every stage of project development. This is the dashboard of our platform. We can see that the location, capacity, investment volume of all the projects in portfolios can be shown and updated timely. For real-time tracking, the entire teams of 50 people will stay informed and aligned. These features enhance transparency and support decision-making based on the current data. It also helps to improve performance and keeps the project on track. The data analysis platform is also something that is easy to use for all of us. It has a user-friendly design, and even without deep data expertise, as long as we have a typical understanding about data, we can use it in a very easy way. Our team can be informed of the project status anytime, collaborate effectively, and adapt to strategy as needed. This flexibility helps us to stay agile and make better decisions throughout the project lifecycle. Our platform and project development services are now available as a standard product. It gives you a cost-effective way to support renewable energy solutions such as solar PV, energy efficiency, process heat, and green hydrogen. It is flexible, customized to the specific needs depending on your resources and operational infrastructure. As part of the GIZ Vision 100, we offer services you can use to implement your own project components. It helps to increase efficiency and scale up the impact of your collective work, accelerating the global energy transition. Talk to us if you are working with renewable energy or energy efficiency partners. You plan a pilot project without installation funding, and or you are working with impact investors to seek viable green projects. Our platform and our services can support your sustainable energy projects and please leverage our GIZ existing outputs to save your time and resources. By adapting past initiatives to your needs, you can enhance efficiency, reduce costs, and maximize impact. That's the end of my presentation. Thank you.
Yeah, thank you, Eunice. Another tool that we could all be benefited from that one. So thank you once again. Now another the story that in the digital innovation for just energy transition. I would like to invite Mr. Prasun Pandey, Manager CLASP, to talk on digital innovations for demand responsive cooling in India and China. Mr. Prasun, the floor is yours, please.
Good morning, everyone. I'm Prasun, working with CLASP in India. Those who do not know CLASP is a global not-for-profit working to improve the energy and environmental performance of appliances that we use in our everyday life. And my presentation is essentially a call for action to stakeholders. So let's dive in. So while this is a global trend, but I would like to talk more about India. So as you see from the charts, the heat stress or the air temperatures have been increasing in India. While India is naturally a warm country, but what's more stressful is that even the humidity levels have started to increase. Now with these trends, the increasing heat stress, now we see more and more the impact of heat stress that's happening in India. More and more number of heat strokes and deaths are being reported. And some of the experts are predicting certain impacts on the economy as well. One of the think tanks estimated that India could lose up to 4.5% of GDP due to heat stress by 2030. Now what common people do in India? While fans and air coolers are mainstay, but to beat humidity, people are buying more and more ACs. And the growth of ACs is, I would say, exponential in India. Last year, India sold 14 million ACs, and by this rate, the stock is expected to double by 2030. Now, why this is problematic? The reason they are problematic because ACs are causing sharper and much higher peaks in the electricity demand, which the electricity system fails to meet and could essentially lead to collapse. There are some efforts to address this problem, but they are coming from the pretty wrong direction, I would say. The investments are being made to increase the grid capacity. But if you see that added capacity is going to be used for just 1% of the time. For the whole of the year, the capacity is going to be unutilized. So we are essentially locking in a whole lot of money in building that infrastructure. One of the ways to address this problem is demand response. So for those who do not know, demand response is all about not supplying electricity, but managing the load that is being passed on to the grid. It could be either by reducing the demand or shifting. And for the past 1 year, CLASP has been working on exploring the ideas, how can we enable ACs to have demand response capabilities built into them so that whenever grid is under stress, they can shift the load, they can lower the set point temperature, or they can be turned off for 5 minutes. It offers a whole lot of potential going ahead in terms of savings. And I'm not talking about electricity savings, but we can essentially avoid up to 12.8 billion that would go into developing the grid infrastructure. And subsequently, there could be a whole lot of savings to consumers as well. Now, if you look at various public policy options to get this into action, we realize that technical standards are very much critical to enabling the policies, the market, the regulations. And standards, those who don't, it's slightly a technical term, but standards are something like the ISO, BIS, or the national agencies define as to how a product should look like. Standards are needed for the purpose of interoperability. So you pick any AC or brand, it should support that functionality. It would help in scaling up the demand response capabilities because all ACs would comply to a particular way of working, so it is scalable. And if standards are in place, there are n number of business models that can be brought to the market. Utilities can work with certain aggregators across various regions. Whenever there is a need for demand response, they can activate those clusters and support the demand response. Now, we talk a bit about how to make this happen, how to support the standard development process. So obviously, we need to make petition to the local standards body or even the global ones as well, the likes of ISO and IEC. And you also need to support a whole lot of stakeholders in getting up to that level. I'm talking about India-specific example. So last year, the Bureau of Indian Standard instituted a committee to look into these standards, and happy to share that right now the work is ongoing to draft such standards in India. Now, while the standards are being developed, we can pretty much focus on developing the capacity of other stakeholders. So manufacturers especially, they can use this time to build their internal case for such a capability in the ACs, undertake their research and development process so that whenever standards are out, they can quickly adopt them. Same goes for utility as well. They can try to create their own internal rationale, the business model, and the potential benefits that they can pass on to the consumers. They can prepare by conducting certain sorts of pilot based on the prototype demand response ACs. A test lab, usually it doesn't come to people's mind, but they are also pretty critical because they are the one who would be certifying if an AC is meeting demand response capability or not. So while the standards are being developed, we must develop their capacity so they are able to test those products and certify whether they are compliant or not. And lastly, I would say policymakers can also contribute by identifying various type of policies or economic incentives that can be passed on to across the stakeholders. While I'm talking about consumers, it could also be for manufacturers and test labs. And lastly, all of this would require certain sort of financing. So in the first phase, we expect certain high-risk finance or capital to be available to various R&D institutions or manufacturers as well to pilot and prototype. Same goes for utilities as well. So we need to explore such a financing pathways. So I'll close my slide with saying that this essentially is a call for action to all the stakeholders. While this is bit India specific, but I could extend it to all the countries. Probably all the standard bodies across all the countries need to explore whether they can develop a particular standard that could support this process. The second aspect is, while the standards are being drafted, let us all work together to create the capacity in the ecosystem across manufacturers, utilities, consumers, and even in the finance ecosystem. And lastly, explore pathways as to when this is ready, how do we quickly scale it up through certain financing options. So with that, I would like to close my presentation, and please feel free to reach out to us, class, or me for any further discussion on this. Thank you.
Yeah, thank you, Prasun. It was really nice also how really it's not just the high level, some policy or plan or some things that we really cannot see, but that really the cooling that's touching to our everyday life, to everyone. So thank you very much once again. Now, may I kindly request to come to the dais Mr. Vikas Upreti, Energy Specialist, GIZ Nepal, to talk on empowering local governments through digital innovation, advancing municipal energy plans for just energy transition. Mr. Vikas, the floor is yours, please.
Thank you, sir. Good morning, everyone. So I'm Vikas Upreti, working with GIZ Nepal, and today I would like to invite you to explore how digital solutions is helping shaping the energy plans of local government through the lens of municipal energy plans, how technology can drive just, inclusive and sustainable energy transitions, empowering communities from the ground. Let's begin with the tale of two local governments. First, Trilok municipalities, where they have a full of ambitions and promises. The mayor envisions to expand modern energy access to its beneficiaries, but behind the scenes, planning is weak and community voice are left. So the result is like the funds are scattered, projects are in piecemeal, and with no technical staff, the projects are still. So as Benjamin Franklin once said, like by failing to prepare, you are preparing to fail. So the results are delays in project and frustrated communities. Now let's turn to another municipalities which has a different pathway. And here energy planning starts from the bottom up. It's participatory. They are including the decisions from the local government's representative, and it's also integrated into energy plans with a dedicated subcommittees. So the municipal energy plans here in Sinduli is not just a document, but it's a driver of real change. So now people have access to modern energy solutions. It's also empowering local communities, providing services and employment opportunities. It's also integrated into their annual plans. And the progress is powered by planning. So what we can learn from these two tales is like the energy plan has been instrumental in providing access to modern energy access in rural communities. It's a periodic roadmap for budgeting and implementing. It's very inclusive, and also like it's a building block for just energy transition. So what is the MEP then? It's a 5-year periodic plan that helps local government to plan, implement, and monitor renewable energy projects and energy efficiency measures. So it's based on target and also based on data, helps to prepare plan. So at the, it follows a structured process. It's a 9-step planning process, which start from identifying stakeholders with a dedicated subcommittees, developing visions for energy projects for 5 years, and so also for more implementation and monitoring. So it's a roadmap for how it's done. So to develop the municipal energy plan, it's also embedded with a GIZ planning tool. So the planning tool at the heart of this municipal energy supports in the various different steps, like collecting baseline data, also in identifying different activities that need to be done by the municipalities. And this is the features of the planning tool. It has a dashboard which provides the overview of different like OpenStreetMaps, populations, the extensions of grid, the different decentralized renewable energy solutions that scatters all over the Nepal, so which will help the local government to understand the energy status quo. So another tool that is helping the local government is this sampling tool. It helps to collect data and also identify where to go for collection in the data. The yellow blocks are the places where the enumerators has to go and collect the data. So furthermore, it also is embedded with the data collection through mobile. So all the questionnaires are embedded can be downloaded in a mobile, and you can collect the data offline. And this data are feed into the systems which automatically generate this infographics, which will be helpful for the local government to plan different activities. So one of the key features that the tool also provides is the best available technologies. For a given settlement, it's always challenging to identify what could be the best technology to electrify that cluster. So it will calculate the levelized cost of electricity for different scenarios and propose like which technology would be suitable for the energy access. Besides these, the local government has the mandate to promote 1 megawatt of micro hydros. So this tool also helps to identify what could be the possible solutions to implement these local hydros in their jurisdiction. So that also, finally, we also have been collecting energy baseline data for households. So it also provides what kind of household technology is used for cooking and what kind of fuel load. And based on that, the local government can design an investment plan from moving from one lower ladder to a higher energy ladder. So that's also provided. And finally, we have this report, the plan report. So the idea of the report is to make it more consistency so that all the local government follows the template. So if they enter the data, the information into the plan, the report is automatically generated. So that's the feature of the tool. So what the innovation in this is like we have done the municipal energy planning since 2018, and this is an example of the local government from Miklajun, where we have seen that there was no access to this local government of 2.51%. The latest census say that now the Miklajun rural municipality has access to 100% of the household. So not only electricity, it also promotes other kinds of activities, rural activities. So it also link activities that promotes economic employment and also boost enterprises and also supports in creating local services. So these are some of the pictures from the grounds where we are providing trainings to the local community. So what is more important is like the process is very inclusive. So all the representatives are taking part of the process, developing the activities. The digital tool is helping them to provide more planned and decision making. And finally, so far we have been able to prepare like 84 municipal energy plans, and the government is also planning to develop 150 local government through the Green Climate Fund. And the NDC has also envisioned to complete like 400 municipal energy plans. So with that, we will have a good number of local government having the municipal energy plan, and this has been also been adopted by many different development partners. In Nepal has been implementing this municipal energy plan. So that's all, and thank you very much.
Thank you, Vikas, for bringing the examples how local government like the digital tools using for their local planning. Thank you. Now the sixth presentation for today. May I kindly invite Mr. Akulur Rahman, CTO Hitachi Energy India, to talk on technologies and digitalization for just energy transition. Akulur, please, the floor is yours.
Thank you, Narayan. And I'm from Hitachi Energy. Good morning to all. I'm from Hitachi Energy. We are into power grid technologies. For us, digitalization is on top of the core technology of the power equipment, power systems, SCADA, automation, and of course, technologies like HVDC. So you see that the energy transition, the entire value chain is changing. I mean, on the one hand, you have more of renewable, more sort of intermittency, and also on the other hand, you have different type of loads coming, hydrogen, electric vehicle, data center. So this calls for predictability, more predictability, and for that, what the owners, operators, they are looking for is reliability, safety, efficiency, flexibility in the system. More of that, and then as OEM, we have to have the connected products with automation, with software, and at the same time, we have to collaborate with the customer. So example of an asset, how it is getting digitalized, you get the data from offline data, SCADA, having the sensors, basically to detect anomalies, to predict failures, have top failure prediction, and also spare part management. So this is an example of asset digitalization. So when it comes to system, all these assets, they have to be connected. The data has to be segregated into SCADA, into historian, and finally you have to bring in the data to the cloud so that it's available for the larger ecosystem, larger service providers who can predict and make the efficiency of the system better. Digital substation, on a substation side from conventional to digital, this is what we have come the way, where it is not just the communication from the copper cable communication, but also fiber optic, basically saving space, time, effort. So this is exactly the benefit of digitalization. From the assets, fleet of assets, it's important to address the system level reliability, because whether it's a substation or transmission line, it has to be reliable in delivering power, not getting interrupted and getting the interruption in the supply of delivery of energy to the consumers. So example also of digitalization is, let's say, a solar rooftop in a plant. It's not just monitoring that, getting the power, but also connected to the grid, predicting the energy generation from the grid, and also ensuring how they are properly coordinated. And another example is the electric vehicle. This is a flash charging of the bus, 20-second flash charging. So how this is connected with the driver, with the passenger, with the grid, with the weather forecasting. So all the different type of data, they are connected, they are segregated and analyzed. And finally, you need to have a asset management, asset and work management center where you can get the data about the entire fleet of assets system to basically improve the performance of the assets, performance of the work of the O&M staff, and also performance of the process. In a system level, example is also smart city, where you have the renewable energy, diverse sources of energy connected with different type of loads, electric vehicle, data center, city, and of course, the cyber security is very important. So creating a backbone with communication technologies, which are more reliable, 99.99%. So we have something called wireless mesh technology, self-healing technology. So the data is not missed. Even millisecond data is not missed in the system, because that may create problem in the power system. So diverse sources of energy, diverse loads, diverse technologies, devices connected. So what's important is all the distributed energy resource management with the digitalization as the backbone. On top of the automation, this provides more predictability in the system, better efficiency, using the digital technologies, even video-based, image-based insights, satellite-based insights, to ensure that the transmission line corridor is not disrupting the vegetation, the forest. So that kind of application we are making with digitalization. Digital twin, a replica of the electrical installation. So that can be used for training, that can be used for monitoring the performance of the assets of the system, and also the training the new workforce in the digitalization, how they can see the energy system in place. And of course, this is a combination of the core automation technology, what we have. We have the sensors which are extending to have the data available, and also on top of the digital technologies, finally achieving the KPIs, the key performance indicators of the system in terms of energy efficiency, and monitoring the entire installation right from generation to transmission to storage to consumption, remotely monitoring on top of the SCADA, on top of the network manager. This is what the digital layer is bringing in for us for the energy transition. So we call it energy and digital world. So the question is, where from we start from? Is it for the existing installation? So we can start from any point, whether it's existing or new installation. So any phase, plan, build, operate or maintain, we can create the digital twin and bring in the digital applications, digital, the solutions. So the starting is always, where do we start from the action point of view? First thing is define the KPIs, what you would like to achieve, what we would like to improve, energy, reliability, efficiency, asset health, and then do the assessment, install the digital like sensors, applications, and then you have the entire cycle sort of continuously improving. And then the goal is that you have the data, you have the visibility from the asset, from the control room to the enterprise level available throughout the life cycle of the installation, the energy transition. And energy transition is, again, not a destination, same as digitalization. I think we have to start somewhere. We have the technologies, start and then go on continuously improving. Start with the key critical items and then move into the entire system and systemic approach. Thank you very much.
Okay, thank you, Akular. Thank you very much. It was really nice. I think we covered the wide spectrum of the energy, where in different sectors where energy is being used, and also starting from the technology, the grid, the cooling system, and also how the local governments are using the digital technologies, digital solutions for local planning. So it was a quite diverse area that digitalization is being used. So thank you all the speakers. Now may I kindly invite all the speakers to come to the dais, and then we will have the questions from the floor, and also you can ask directly through mic, and also you can ask the app, web app, so whatever you like. So then I will request to, so basically I will read out the questions, and then if specific speakers mention in the question, that I will ask in the same way also. If the general, whoever appropriate, whoever would like to respond can respond to. So please, speakers, all the speakers, could you please come to the dais? No, wherever you like. So just wherever you find free seats, wherever you like. So it's a free seating arrangement. So thank you once again. So before going to the specific questions that I received through the app, and also maybe the audience also may ask, I have very much the general type of questions that to all of you. So you shared really the the impact and also good thing. And as I also a bit brought that issue that it's not free of challenges, so always. So, and also because if it would have been much easier, we could have been not here, maybe somewhere else, because there are plenty of challenges that hindering the progress of digitalization in energy transition. So one by one, just basically in the area that whatever you presented, so what might be the biggest challenges, one or two that you faced, that also might be useful for the policymakers, planners, development activists to plan, to be better prepared in the future. So who would like to start? So one by one, not one, two challenges, the biggest challenges that you think that in your specific areas. So please, whoever would like. Yeah, yeah, Kulur, please.
So we have the technologies, the core technology, and also the digital technology solutions there. But the challenges our customers, the owners, operators, they also face is that while the system is running, the power system, the power grid is already operating. So how do you bring in the new technology which should not disrupt or interrupt the process of the power, whether it's generation, transmission, or distribution? That's the main thing. And then we have that, actually we do take care of that, not interrupting or disrupting the system while you bring in the new technology. That's there. The second aspect is, of course, the financing, because this is not part of the utility or the industry sort of operational budget, or so they always find it very difficult to fund the new projects. I think there agencies like ADB and many funding agencies, they can really support the utilities and industry. And especially here, it is very tangible benefits what they get. I think it's not difficult to justify the investment, but it's all about how we can come together to bring this system set up and running and get the benefit of the digitalization. Thank you.
Yeah, thank you. Thank you, Akula. So who would like to come next?
In our study, we encountered two types of challenges, and they're like 180-degree across. One is consumer behavior. So when we are talking about modulating the output of an AC, for us, as of now, there is no benchmark or yardstick to think that a consumer would be fine with changing the AC set point or turning it off. So we had to complement our assumption with certain small surveys. But this is still a larger thing that we need to understand fully. And second, obviously, is largely around the technical standards, and this is slightly technical. When we are advocating for demand response capability in a particular product or device, we have to ensure that they are interoperable, so that any model or any make could talk to the grid or program operator. So how do we ensure the interoperability among devices is something of a challenge. And there is no industry-wide standard or industry-accepted standard that is already available. So we are pretty much advocating for creation of a new sort of standard. So for example, Wi-Fi is an industry open standard that everyone follows, but there is no such standard when it comes to demand response.
Okay, thank you, Prasun. GIZ, please.
Basically, there are multiple challenges while implementing municipal energy plans, but the one that I see most challenge is basically the data, the collection of data that, because while developing these municipal energy plans, we rely on multiple data sets like the access of different technologies, the grid networks, and the local governments are also implementing their projects. These are not digitized. So without having enough information on all these technologies which are on the ground, this will not help to create activities which are more close to the community. So that information is lacking, and though the tool have some features where we are trying to collect manually those data, if those data are easily available through different agencies, I think planning would be more easy. Another challenge that what I see is the lack of the technical expertise within the municipalities, since they don't have enough technical human resources. So the plan is good, but implementing these plans needs a lot of supports from the different agencies who are implementing or supporting in preparing these plans. The post supports are quite necessary for developing the activities which has been envisioned in the plan. So these are the two major challenges what I foresee while implementing the municipal energy plans.
Okay, thank you, Vikas. Would like to come? Max, please.
Yeah, thank you for the question. I really like the question because, I think we can really learn a lot from that. For us, in 2020, that was still during COVID, right? And we wanted to digitalize everything. All meetings were digitalized. We were meeting virtually. And we were very ambitious because we expected also like a forum, like a Facebook of the development partner community, to create that on our platform where people could exchange on and submit project proposals, and we found nobody used it. So that was really disappointing, and then we also abolished the idea. The second really challenge is to get partners on board, especially for the project mapping, to upload the information constantly and update it and keep it updated. But we have now reached, I think, quite a size where we cover a broad portion of the projects in the region, so people are now interested in making a lot of use of that. And the third challenge is, I think, that we work with many partners, and there's a lot of coordination which needs to take place. But there's also real benefit because so many perspectives are shared, and then, yeah, I think many see that in the tools which we provide. Yeah, thank you.
Yeah, thank you, Max. Amy or Eunice who would like to come?
Hello.
Yeah, please.
Yeah. So for our side, because we are doing data management, so it means like everything we put online, we interact through the platform. So what if one day the platform happened to retire suddenly, like for a few days, like just call off? So we always have to think like if we depend on the system for communication, for our progress monitoring, then we should have a plan B. Like for example, we still have to like call a meeting to like just to pass the time where the developer or the technician is fixing our platform. And also the second thing I think is even though we embed a lot of calculation through the platform, but there are always mistakes somewhere. So we always have to cross-check to like, because I also mentioned about 4 eyes principle. So it means one person do, the other person have to check. So we always have at least 2 person check for one single result. And yeah, to us, what I believe is it should be a tool. Digital should be a tool, not replacing us, because we are working directly with the customer, and we always have to maintain our sharp eyes, sharp mind to like use the tool and also to help us with the work. Yeah, that's from my side.
Yeah, thank you, Eunice. Amy, please.
Okay, yeah, the challenges actually because of this technology is new, Solaris Maker is new, and this is like the advanced technology, but we would like to install in the remote and local community, meaning in the future, so we don't want to make it more complex. That's why thanks to the digital as the tools to support us, like providing the parameter that influence the operation of the system, so we make it more digitalized, and then the operator can observe and also can get the information from the system. So meaning it helps a lot for the fishers and operator to use this technology and get the impact for this technology to produce the ice block for them to catch, to maintain the fish and get the better price. Yeah.
Yeah. Okay, so before going to the audience, I have some questions already over. Let's there are 2 questions basically. There are some others general, very difficult to have that one, but the 2 demand response refrigeration and ACs, maybe both of them the person would be, or anyone others also would be able to respond to. So I will read out. How are the demand responsive refrigeration and air conditions progressing with updating of national standards? Maybe that is the first one, then I will come to this next one.
Yes. So the updates on demand response are quite encouraging. So last year, China did a field pilot in one of the municipality, and wherein the business case for demand response was very well proven. Based on that pilot, there is some domestic development that is happening in China as well. And talking about India, I would say the Bureau of Indian Standard last year constituted a committee that is exploring this opportunity. We are trying to support BIS in that process, and we have conducted a lot of, I would say, primary and secondary research to support this development process. In our research, we found that in some states, like the likes of California and in Australia, the demand response has a certain type of standards have already been drafted, but they are not specific to ACs. But we are trying to take best out of those standards and putting into the perspective for room air conditioners or ACs. So in a nutshell, I would say the progress is encouraging, but the final results are yet to be out.
Okay, thank you. Thank you, Prasun. Also, the next also relevant to you. How are the demand responsive ACs different from the 5-star energy efficient ACs available in India? Please.
Yes. So 5-star AC is all about being energy efficient. So as compared to a typical 3-star, they would be consuming almost 20 to 25% less energy. But that is one aspect. The second aspect, when there is a peak load demand in the country, your grid is unstable. So what the demand response AC, they could be 3-star or 5-star as well, but they would have functionality to turn them off for 5 minutes. Or they could change their set point automatically based on the signal it receives from grid or grid operator or discom. So consider this, you are running your AC at 18 degrees set point, but your utility tells you that I am facing stress in managing the peak load. Can you change your set point from 16 degrees to say 26 or 28 degrees for the period of 10 minutes? So what it does is it essentially reduces the load that it puts on the grid for the time being. So that essentially is demand responsiveness. So an AC that is DR enabled can modulate its output, or it can turn itself off for a certain short or brief period of time. So that essentially is the DR enabled AC.
Akilur, you would like to come?
Yeah, maybe I can add it from the grid point of view. I think this is a very good sort of concept of demand response based AC. Here, with respect to digital technologies, I think we can use the AI very much to, because the demand for the AC, the cooling, it is not a linear thing. I mean, there are so many factors. If you look at the weather, the people, the region, and whether it is holiday or it is working day, so many factors. So you can't put them into one equation or multiple equations. So this is where exactly the AI can help in terms of analyzing the data and then creating the pattern, which will help the AC to be demand response, how it can change itself, but also the grid to forecast in a real-time basis that how the demand is going to change and how the grid has to adjust to itself in terms of providing the power. And also it's something similar to the load shedding what we have. So the AC itself is getting sort of adjusted depending on the power availability. So it's a good concept, and here I think the core technology of demand response as well as digital AI can be used together to make it more efficient. Yeah.
And just to add on to what Akhil just said is like, while we are starting with ACs, but the end of the line vision is that maybe other potent or energy intensive devices could also be provided with this functionality. I'm largely talking about water heaters and others as well.
Okay, so before I move to the audience, there is a questions coming from through app. That's the what additional feature your tools could be added to make it a bit the better. So that's the question coming in. So I will come at the end as like elevator pitch. So it will be very, very short one. So that also, in order to make the justice to the audience also, now I need to move to the audience. So please come to the mic or write your questions so I can get that one also. Whatever you like, please introduce yourself and general questions, or you would like to address to specific speakers. That's up to you now. It's the chance for the audience to ask their questions. Please. So anyone can go near to the mic or can ask through the app. That's whatever the going to the mic would be better. So because that is lively. Yep, with your introduction, please.
Yeah, thank you for giving me this opportunity. I just wish to add one or two more points to the question you raised about the difference between the DR-enabled AC and the 5-star AC. I am from Delhi, a BSES Rajdhani Power Limited. We are in electricity distribution business. And it is a part of our kitty of all this initiative, basically energy efficiency, automation, digitization, and ADR capability building. This topic is really very important in the sense that mainly the peak is being driven by cooling needs. And the heavy investment is required only, as Prasun rightly said, the peak is coming hardly for few hours in a year. For example, in Delhi, it's hardly 30 hours in a year we face a severe peak. The difference in peak is, you can just imagine, in the winter season, Delhi peak is around 2000 megawatt, but in summer we reach up to 9000, 8500 megawatt. In the same day, in the one day in the summer, the morning hours load is hardly around 3000 megawatt, but the evening night hours peak load is around 8500 megawatt. Now utilization of grid is really very poor, and to add just 1 megawatt distribution capacity, it needs around 15 crore rupees only for distribution network. Now if we have any capability, and nowadays fortunately most of the equipment are smart. Smart, I mean it has a digital capability, and that can interact with any other advanced tools, application, where it can help us to optimize the energy consumption as well as peak reduction plan. Now that has nothing to do with the comfort of the consumer, the purpose of the appliance to installation of the consumer, but there are certain flexibility, as we said, that 1 degree increase in air condition temperature can reduce 7% energy consumption. So there is a massive potential, but unfortunate part, what we see as a utility is that all the smart device has a two common feature. One is adding a smartness related to the consumer need. Basically, they're not, sorry, they need a visualization of what is happening in the device, certain data, certain application, certain use case.
Okay.
At the same time.
Thank you. Maybe just in order, just.
Yeah, thank you.
Yeah, thank you very much. Valuable input. So as I have a limited time, so I also need to address the one thing that how can the demand response be better modulated? That also somehow related to the last round. So please start where would like to start. What is the additional feature that you would like to be added in your tools that would be better? So very fast, 30 seconds on an average.
So actually, we are closely working with Alternative Energy Promotion Center, the nodal agency for promoting decentralized renewable energy and energy efficiency measures in Nepal. So they are implementing this National Renewable Energy Management Information System. So I want that tool to be used by the local government so that this data can be integrated into our GIS-based planning tool. So that's the feature that I would like to see.
Okay, thank you.
Given our work is still ongoing, so I would like to reiterate the call for action. I look forward to collaboration and working with manufacturers, DISCOMs, utilities, as well as various other stakeholders in driving this DR initiative forward.
Yeah. Thank you.
Let me dream a bit, but the last couple of days I heard a lot about the ASEAN Power Grid, and if I could add a tool on our website, I think it would show live data on electricity trading from the region, and I know that's impossible due to data sharing and so on, but I think that would be great and really show the case on how it's already happening.
Thank you.
Yeah, for us, Hitachi Energy, so it's not tool, it's more like digital solutions to the customer, to the utilities. I think we have to make it affordable the way we also talk about energy to be affordable, because we have very advanced, sophisticated solutions, but at the end, the utility or industry, when they adapt, they also look for starting with a base case. I mean, that's how we have to do it. Start with basic and then make it scalable, modular, and then so make it affordable to start with. Yeah, thank you.
Thank you. So, Amy, please.
Okay, yeah. So for this, as I mentioned before, that this is the digital tools. So meaning that still have the effort to improve and improve again to get the more impact and also benefit for the digital tools. So I can say that this digital will help a lot actually for making this technology more advanced, but also more give impact to the users and operator, for example. Thank you.
So for us, we are rolling out a new feature of opening the platform to our customer. So in the future, if you are working with GIZ project development program, you can submit requests, monitor the progress, and also interact with us through all the steps of green investment project. So stay tuned, please.
Thank you. And now we are almost near to the closing. So maybe the photographers just to take a group photograph before, just to be ready. So now just the thank you to all of you, the speakers, and also the audience, and also the viewers, whoever asked the questions, and for your contributions. So without you, we could not do the things that we did. So thank you very much appreciated. Just even after the break, we will have a bit different setup, but please also join after the break, because then same topics that we will go till lunch, 12:30. So there will be no like the presentation that we had in this session, but there will be one keynote speech from the Undersecretary Dr. Govera from the Department of Energy from the Philippines, and there will be other like the panel discussion moderated by Jacqueline. Thank you, Jacqueline, that you really accepted to partner together with us. So all the speakers, basically all the partners, the Kilur representing Hitachi, and also Prasun representing CLASP, and also all other partners, whoever agreed to partner with us and came to our session today. Thank you all of you, and just see you after the break in half an hour. So group photograph, please. Good morning, all of you. Welcome back again to our session, Digital Innovations for Just Energy Transition. So we had the first half just before the break. Now we would like to bring a bit new stories, the tools most probably, also the new points, what we can bring to the just energy transition, the digital solutions, digital tools. So what are the things that we can do? So welcome back to all of you again. So we have a bit, we don't have except the keynote speech, we don't have the presentations. Basically that the discussion will be moderated by our the moderator. So before that, I would like to invite our keynote speaker. So basically, the digital innovations for clean energy transition are perspective from a liberalized market. Dr. Rovena Cristina Govera, Undersecretary of the Department of Energy, the Philippines, to bring you a bit so that the panel discussion would be a bit easier, also to bring you in one place, so also that is what we are hoping. So Dr. Govera, please come to the dais and the floor to you, please.
Good morning, distinguished guests, partners, and fellow advocates of the clean energy transition. It is an honor to speak before you today to share perspective on how digital innovations are driving the clean energy transformation in a liberalized market like the Philippines. As we stand at the crossroads of rising energy demand, worsening climate impacts, and the urgent call for sustainability, the message is clear. The future of energy is clean and it is digital. Let us make sure that we are on the same page. I'm a teacher, so I need to do this. When we talk about digitization, this is about converting and recording data into digital form. For example, if you have people putting in their scanned copies of their forms, that is not digital because possibly an OCR will not be able to read it. But if you ask people to key in their answers, that will give you digital information. And then digitalization is developing processes and changing workflows to improve manual systems that have digitized data. This is where many people make mistakes. They think that if you just use a computer to digitalize a process, that is fine. But many times, the process itself needs to be streamlined first before you digitalize it. Third, innovation. I got this from the Department of Science and Technology. It's a process, a product, or service which is new, original, or improved that is applied to create value. So if something does not have value, it is not an innovation. It's just a bright idea. The clean energy transition is shifting from fossil fuel to renewable energy and clean technologies. Most people forget like nuclear is clean technology. So this is part of the clean energy transition. In the Philippines, nuclear has a place. And lastly, the liberalized market. You know, in 2001, the Electric Power Industry Reform Act of the Philippines shifted hands from the public sector to the private sector, the entire energy sector of the Philippines. So in the Philippines, we talk about generation companies taking care of producing energy. We have distribution utilities, and we also have one transmission operator. Now, the Philippine energy sector is a 3.3 trillion industry. As of March 2025, the current players are shown here. And transitioning to cleaner energy will require 28 to 31 trillion pesos in investments. But it will generate 2 million jobs, or green jobs, supporting both infrastructure and our workforce. Now, the title of this session is Just Energy. When you talk about justice, you have to be able to cover the least of our people. So shown here is the University of Southeastern Philippines professor, Engineer Philman Simpao. I've known him for like 5 years. He's showing here a pay-as-you-go payment system for solar home systems to help in the electrification of communities that are far from commercial power lines. It uses radio frequency identification and low-power wireless area network technology connected to a GIZ, which is a system with a control module to provide electricity and lighting to households in the selected community. He chose an indigenous people community for this project. Before P-Solar, the community was reliant on kerosene to light their homes. Using a solar home system for the community is the logical solution, as they only need electricity for lighting, basic services, and for charging mobile devices. However, a solar home system costs thousands of pesos and is too steep a price for a community that is reliant on small-scale farming. P-Solar is a sustainable system, and the users become responsible for paying their electricity in manageable amounts. So they have a tap card, and they load the card, and then the electricity will flow. Piso is the Philippine money. So P-Solar, with just a peso, you'll be able to power your house. And they will eventually be able to pay for the solar home system in installment. The Philippines is one of those sachet economy. We don't buy our shampoo in bottles, we buy them in sachet, used for one shampooing session. Now, this translates into our electricity. So there's what's called the prepaid electricity. So the nice thing about the prepaid electricity is that it uses digital technology. They use a cell phone to figure out how much of the prepaid load is remaining, and they can actually monitor the electricity consumption each day. And this is good for people who are moving from one place to another. So you just load your phone, connect it to your meter, and then you're set. And you only use the amount of, or you only pay for the amount of electricity that you're willing to pay for and consume. This helps the consumer regulate their own usage. This is putting the power of electricity in the hands of the consumer. Consumers today are no longer passive users. They are becoming prosumers, producers and consumers, generating and managing their own energy. We are enhancing our net metering policies. We're also doing peer-to-peer energy trading. I was surprised to learn that one village here in Metro Manila is using blockchain to do peer-to-peer trading on their solar rooftop. So that's digital technology working for you. And we also have a green energy option program wherein a consumer of a certain amount of kilowatts peak can actually ask, I want 100% renewables for my electricity. And it is our dream that 5 years down the road, this can be done at the household level. And soon we will have what is called the voluntary renewable energy market. All of this will be powered by advanced metering infrastructure, allowing transparent real-time energy data exchange. Next, we are using digital solutions to expand electrification, especially in off-grid areas. Under the Microgrid Systems Act, we are deploying distributed energy resources supported by advanced metering, digital microgrid control systems, and we have a crowdsourcing platform to identify the unserved households and communities. It's very difficult to look for the unserved households because they don't have electricity. If we use satellite data, we cannot find them. So we use crowdsourcing, and people actually key in this location. There are several houses without electricity. And that's how our program for electrification can target those locations where it is most needed. This ensures that no Filipino is left in the dark. Now, allow me to give a nice example from Winergy, Sabang Renewable Energy Corp, Clean Grow, and Maharlika Clean Power Holdings Corporation. So this is a group of people who came together to operate a microgrid system in Sabang Island. The power supply is a combination of solar, battery, and diesel, powering over 550 homes. The household income level has shifted. Because of this, after 5 years, before it was less than 1,000 pesos per month, and now it is from 1,000 pesos to 30,000 pesos. They also have sustainable appliances. It is now available among residential consumers, so electric fans, being able to charge their cell phones, a refrigerator, so they could do small business in their houses. And we also have 100% of schools having all of this, a fan, TV, computer, laptop, printer, sound system. And then access to electricity, from no electricity to majority having 16 to 24 hours of electricity. We came up with a study that shows the benefits of electrification. And we found out this. If you increase electrification from 0 to 8 hours, the income increases by about 17 to 18%. If you increase electricity access from 8 hours to 16 hours, income increases by 33%. And if you go from 16 hours to 24 hours, the income increases by 50%. So imagine this. They were able to do their green energy transition in a small island, and because of the availability of electricity, the economy of the island already improved. And based on their data, It has improved by 18% today. Now, I mentioned this example because we're talking about just energy transition. Nobody should be left behind. On February 6, 2020, the Department of Energy issued a department circular providing a national smart green grid policy framework for the Philippine electric power industry and roadmap for distribution utilities. In collaboration with USADSP, the University of the Philippines, and Transco, we have taken the initiative to formulate what's called the Smart and Green Grid Plan that will establish a robust policy and mechanism for timely transmission project implementation and efficient system operation. With all of the renewables coming online, it takes 1.5 years to build a solar power plant, but it takes 5 years to get right-of-way and to build transmission towers and string the transmission lines. So there's a disparity. 1.5 to 2 years for a power plant, 5 years to build the transmission line. And that's why we had to come up with a policy that will enable the building of what we call the smart and green grid. We're also exploring grid-forming inverter technologies to stabilize an increasingly decentralized grid. In the past, when you talk about building a power plant, you're talking about 100 megawatts to 600 megawatts. Today, we have power plants that are 1 megawatt to 5 megawatts and decentralized. Around the world, countries like the United States, particularly through the New York Independent System Operator, have deployed advanced demand response systems. These include smart thermostats that modulate AC units during peak demand and direct control over electric water heaters and pool pumps. Load forecasting systems also help flatten consumption curves in real time, preventing spikes that would otherwise strain generation. These technologies ensure reliability without significantly affecting user comfort. In the Philippines, while digital demand response is still emerging, initiatives like the rollout of the advanced metering infrastructure are laying a solid foundation for two-way communication between the utilities and the end users. I trust that in the panel today, we will learn more about these systems. Data is power. So the Department of Energy, we have an electric power database management system, or DEP-DPMS, that collects industry data securely and efficiently. Soon, it will include tools to identify unenergized areas, enabling better targeting for distributed energy systems and microgrid investments. We're also developing a renewable energy data warehouse powered by AI to support evidence-based policymaking. Digitalization also enabled the success of our green energy auctions, which awarded over 5.3 gigawatts of renewable energy capacity. By digitizing the auction process, we fostered competition, transparency, and better price discovery. Beyond generation and grids, digital innovation empowers consumers directly. Under the Energy Efficiency and Conservation Act and Electric Vehicle Industry Development Act, we aim to achieve 10% energy savings by 2040, reach 50% electric vehicle penetration in road transport. And this depends on energy management systems. How do you make sure that your car will get you to the destination before running out of charge? We also need smart meters and controls, digital apps for energy tracking, and EV charging platforms. On the bigger picture, we have the Wholesale Electricity Spot Market, or WESM. It is a centralized venue for trading large-scale buyers and sellers of electricity, where price is based on the interaction of demand and supply. Commercial operation of WESM Luzon started in June 2006. Visayas started in December 2010, and WESM in Mindanao started just in December 2022. But after 1 year of operation of WESM Mindanao, the price of electricity there went down by 1 peso per kilowatt hour. The reserve market is integrated into the wholesale electricity spot market last January 2024. The reserve market aims to co-optimize energy and reserves which result in optimal schedules and prices for energy and reserve requirements, fostering competition, affordability, while ensuring grid security and reliability. The renewable energy market serves as the venue for buying and selling renewable energy certificates, or RECs, equivalent to an amount of power of 1 megawatt hour per REC. It is intended as a facility for mandated participants to comply with the Renewable Portfolio Standard or obligations. The nice thing about this is that we can make sure by adjusting the Renewable Portfolio Standard from 1% to 2.52% increase per year, we are going to achieve 35% renewable energy in the generation mix by 2030. To date, the Department of Energy has awarded 1,411 RE contracts with a potential capacity of 153.8 gigawatts. Of this, 6.9 gigawatts is already installed. How can you manage this number of renewable energy contracts if you have not digitalized? We use digital technology to help energy developers in processing consents and permits through the Energy Virtual One-Stop Shop. This is very dangerous to us at the Department of Energy. The EVOS, if somebody submits an application and the EVOS says it will be processed in 31 days, if we fail to process it in 31 days, it is deemed approved. So our people are very busy making sure that all of the applications there are on time. EVOS takes full advantage of digitalization and digitization. Our personnel do not need to retype data submitted by RE developers. EVOS generates reports, reminders for users, and track the status of project applications. As of today, a total of 53 processes are now incorporated in EVOS system from 10 national government agencies, not just the Department of Energy, 2 local government units. And there are 3 local government units that integrated their system for the issuance of business permit. Now, the green energy auction provides a market for RE through competitive electronic bidding of RE capacities. As you can see from our auction, we have some degree of success in getting our renewable energy online. Next slide, please. Demand response programs succeed when they are supported by the right mix of policy, finance, and technology. In the Philippines, programs like net metering and green energy option are cultivating a more engaged and energy-literate consumer base. We're also seeing emerging models like peer-to-peer energy trading under the expanded solar program. This is where digital, decentralized, and consumer-driven systems converge. This framework not only empowers consumers, but creates fertile ground for future DR mechanisms. While we talk about digital innovations for clean energy transition, we must keep in mind that the best demand-side management are people. Last year, during the El Nino, our reserves were very thin. One plant goes down, the whole thing breaks down. So what did we do? We made a public appeal and asked the consumers to shift their use of large appliances to hours when there is enough supply. You can hear housewives talking about, oh, I have to do my laundry tonight rather than this morning because I need to help the department secure the energy supply. So it was so nice to hear people able to talk at that level. And it worked, and we finished summer last year without any major power outage. So the adoption of any innovation starts with people who understand the benefits of innovation. Thank you for your attention. May we have positive energy throughout the day.
Thank you. It was really wonderful, that really setting the scene how we can start the the panel discussion. It was really nice. Thank you very much, Honor Secretary Dr. Govera, really bringing the real stories, real, not something theoretical, but the real practical examples from the Philippines that many countries in this Asia-Pacific region also we could follow that one. So thank you very much. It was really, really helpful for us, for the whole audience also to know what and how Philippines is doing. So now, in order to move to the panel discussion, our panel theme, though the whole session is called Digital Innovation for Just Energy Transition, we will focus a bit more, deeper in the panel discussion in the theme that enabling just energy transition through digitalization for appliance level demand response and grid resilience. It's not just electricity, but also the cooking and the demand response, the cooling, whatever that might be. That's we have also the diverse the message, also the diverse the field of expertise that we will bring here during the panel discussion. In order to move that, now I will hand over the mic to our session moderator, Ms. Jacqueline Lam. She is the Regional Director for Asia at Sustainable Energy for All. And thank you from the organizer perspective, and thank you very much for accepting to partner with us to organize this session. And thank you very much. Now, the floor is yours, Jacqueline, please.
Good afternoon, good morning, colleagues. It's an honor to be here. Very big shoes to fill after Undersecretary's very rousing presentation with all of the really important points around how we rally together and how we really look at different levels of utilization of innovation and digitalization to really accelerate just energy transition. With that, let me also now welcome on stage Dr. Kuang Nguyen Mao, who is the head of Siemens Power Technologies International, who will also share some global perspectives around the technologies that Siemens, of course, is demonstrating on this topic. Thank you.
Thank you, Jacqueline. Thank you for having me today. So on behalf of Siemens, firstly, I want to share with you what Siemens doing in digital world now. So maybe you think about when you hear about Siemens, you can hear about, okay, handy, you hear about transformer, we hear about the circuit breaker and so on. But actually now, Siemens, we are the technology company. So if you hear from the press, we spend 15 billion US dollar for acquire the AI company, software company, and what is the reason behind? So Siemens now is one of our slogan is we connect between digital world and real world. Yeah. So to do to do so, we need a lot of technology mindset, right? So we talk about how we build up the digital world by different solutions like sensor, like SCADA system, like metering data, right? Right. So at the end of the day, we have the data. So digital world is we talk about the data, right? And now what should we do with data? We need to have the application, right, to mining the data, right? And that's why at the first level of our solution, how we digitalize our world to get the data. And the next level of Siemens, we build the different app, different application, different software to help customer to really, let's say, have the deep view into their system, into their network and into their data to, let's say, application, for example, for building, yeah, how you can building, how you can manage the metering device in your house here. And actually that is the solution we implementing now in Meralco in Philippines. We call this is the metering data management system. Yeah, so we let the device, let the metering have raise their voice, so we can let's optimize planning and so on. This is for metering, and for the distribution network, we also have supplied the software to build up the digital twin of the distribution network of Meralco. We call that the software PSSE. For NGCP, we also provide the solution for the software, yeah, called PSSE. That's to make the digital twin between the real device, real transformer, real cable, real transmission line to the software. And from that, you can connect to metering data, and you have the real data, connect the real data to the digital twin of your network, and then from that, you can make better planning. You can have the clear future view of your grid data, right? And that is an example how Siemens can have to accelerate the just energy transition by building data, the app to build up the better planning. And for GIZ, for example, because it's GIZ, we can give you the how we cooperate with GIZ in just energy transition, because we talk about the hydrogen, green hydrogens. So in GIZ Vietnam, we build up the green hydrogen hub, right? So Siemens joined there, and we the beauty that in Vietnam we have a German company, German Vietnamese company. They can build small scale hydrogen electrolyzer, 1 megawatt, for example. Green hydrogen, the power go directly from solar to the electrolyzer to build up the green hydrogen. So what Siemens help them, we provide them the AI SCADA system, because when you have a lot of device, you cannot, let's say, operate by human. You need to have support of AI. So we provide them, and we also provide them the technical due diligence, because this is a new technology, and we need to have the fund from the bank, commercial bank, from different financial. So we help them to make the technical due diligence, and then just really bring the green hydrogen into the world. Yeah. Okay. Due to the time, I think that's what I want to share with you, and hope we can have deep dive discussion in the panelists. Thank you.
Thank you very much, Dr. Gong. And up next, we have Ms. Reena Suri, who is the Executive Director of the India Smart Grid Forum, to bring us some examples from South Asia. Thank you. Over to you, Ms. Reena.
Sorry. A very good morning to all, and thank you to GIZ for having me here as part of the panel. Sorry. So a lot has been discussed around, how technologies are playing a key role in supporting nations in just transition. And one of the key challenges, particularly, that we see in this part of the world, South Asia and ASEAN region, is the growing temperatures, which is also adding to a lot of new demand sources, and cooling, which is rapidly becoming one of the most pressing challenges in managing electricity, in particularly in the rapidly urbanizing and warming countries, like taking examples from India. And during the peak summer months, the cooling loads in buildings and the amount of electricity demand load is increasing is to the tune of 60%. And this is just the beginning, and with the climate change that we are looking at. And only 10 to 12% of the Indian households currently, if we see the scenario, they have ACs as of now. And as the temperatures rise, they'll be breaking new records each year, and millions of new ACs are going to get added. As last year we have seen itself, India has maximum temperature rose to 53 degrees Celsius. And we have found that the ACs and even the car ACs have not been performing as well because of the rising temperatures. So this incremental efficiency improvement, even though Indian government has been working very, very strongly towards bringing efficient appliances, particularly ACs, we have 4-star and 5-star ACs. But still, these improvements will be overtaken by the load of new ACs which will be getting added because of the temperatures going higher. So this cooling load management is a real challenge, and demand response is going to play a key role in supporting the extra new load that is getting added. So with smart technologies, we can shift the energy use from peak hours to off-peak periods without compromising the consumer comfort. And we have seen the many examples of intelligent load controllers and Wi-Fi enabled smart air conditioners playing a key role to automate the response towards the pricing signals by the utilities and reducing the grid stress. So we can automate this process, and this is going to help flatten the peak and reduce the electricity costs, and even lower emissions if the peak is being met with fossil-based power. And in India, we have seen several demand response projects which have been initiated to support these efforts and have seen very encouraging results. Many utilities have seen close to 15 to 30% reduction in the load with demand response initiatives that they have taken. But of course, consumer engagement and involvement was a key apart from having the right technology and the right appliances available. So and we had seen the use of smart plugs, cloud-based control systems playing a key role here. And overall, the projects showcased that the DR, automated DR in urban settings, and underlined importance of consumer engagement, and the utility system integration was a key in any of these successful deployments. Another angle I want to bring today, and a lot has been talked about DR with appliances and particularly cooling. But ISTF has also been advocating for district cooling systems, and which can produce chilled water at a central location and send to large number of buildings through insulated pipes and for air conditioning. And individual buildings shall have only air handling units available. And the electricity demand with the district cooling systems will be less than half, compared to each building having their own centralized AC units, and could offer efficient cooling even at temperatures which are above 50 degrees. So these DCS could offer demand response to the grid in megawatts, and can support the distribution grid in managing their peak demand. And when we have surplus power during high solar generation hours, so when we talk about the just transition and so much of renewables coming into the picture, during the surplus hour, the DCS could produce chilled water and insulate the tanks, and during the off-peak hours, during the peak hours, it can provide load relief to the grid by switching off the compressors and still cool the building with the chilled water. So, and many, a lot of work has been done towards making these initiatives possible. There have been guidelines on DCS which was supported by GIZ in India, and today there are over dozens of DCS projects completed, and another hundreds, DCS projects which are under construction. So I would like to conclude my introductory remarks by saying that this intelligent demand side management will support the energy transition that we are looking for, and the world is looking forward to enabling cleaner, more flexible grids and reduce the reliance on fossil fuel during peak hour with all the innovations and regulatory support going forward. So thank you so much.
Thank you very much, Ms. Rina. And up next, I have our expert on renewable energy and demand response appliances, Mr. Prasoon Pandey from CLASP. Thank you. Over to you, Mr. Prasoon.
I would like to start by thanking Undersecretary Ma'am and Lina Ma'am for setting a perfect stage for me. Ma'am, you very well explained what demand response is. Essentially, we shift our usage to some other time. And Lina Ma'am summarizing the overall ecosystem. So this makes my job very easier. So what we have been working on recently is essentially automating that shifting behavior. While as of now, we do it manually, but we were trying to think of a way how to automate this. Whenever the grid is under stress, the appliances could automatically shift to that operating characteristics. Now, why there's a need for it? So I'm slightly going to talk from India's perspective because that's where this has been ongoing. So in India, there are policy instruments which are addressing the efficiency part of the problem. That is, ma'am also hinted about it, that more and more efficient ACs are being promoted through various government schemes. But none of the policy instrument right now is looking at managing the peak load that they are contributing to. Suri ma'am also hinted about the smart plugs and various others. But if you analyze those solutions at a deeper level, you would see the problems related to replicability in them. So while pilots have been very encouraging with them, but as an end of vision, you have to look at the interoperability among various appliances, the scaling potential, and how easily DISCOM can aggregate those appliances to maybe offset certain load. And this is where the role of standards come into picture. So product standard, if written in a way that include the smart capabilities within the product itself. So all manufacturers would be mandated in some future years that all appliances should have that smart capability built into themselves, and they could be interacting with grid in the real time, while that may enhance cost of the device marginally, but when look from the energy planning and utility demand side planning, this could very well make sense. So for the past 1.5 years, we have been trying to discuss this proposition with stakeholders in India, including the standard bodies, manufacturers, utilities as well. And we have, I would say, support very positive response from most of the stakeholders. Based on the joint recommendation of all the stakeholders, the standard body of India right now is exploring whether they can come up with certain standards which addresses this. And luckily enough, we found that in countries like Australia, as well as in few states in USA, there are already demand response related standards which are already in play. They are yet to be made mandatory. As a typical public policy option, you start with a voluntary phase. You give people or manufacturers or anyone else certain time to build their capacity, maybe 2 or 3 years, and then you start to mandate. So Australia already has one standard that they are looking to push further. Same goes for a few other localities, states in USA. So this gives us a very good precedence what are the certain best practices elsewhere in the globe and how to integrate them in Indian standards. So this, I would say, is happening as of now. The committees do, the standard committee is convened regularly, wherein they do discuss the ongoing best practices across the standards and how well it would be integrated in Indian AC standards. The last few seconds, I would like to again take an opportunity requesting all the stakeholders to maybe build a better case for such standards in their localities or local communities. Manufacturers should evaluate and be ready. Manufacturers are the ones who essentially provide most of the inputs for standard making processes, be it ISO, IEC, or national standard making bodies. So they could start their own internal research and research to assess what would it take to support this standard development process. Almost, I would say, a similar call for action for utilities as well. They could start to analyze the potential benefits they would have, the technical aspects that they would need in the products so that they could upscale and develop DR-related programs. Lastly, but not least, the test lab capacity building is also very important. Once a product is developed, we need to be sure, or not exactly sure, those products need to be certified if they are demand response ready. So that capacity is also very critical to be built into the system. And lastly, I think policymakers would need to evaluate the potential benefits, and based on the cost-benefit analysis, they could try to catalyze such activities in their respective nations. With that, I would like to thank you, ADB and organizers for the opportunity. Thank you.
Thank you very much, Prasoon. I'm getting my steps in today from just going up and down. We've heard so much about cooling appliances in the Indian context. Right now, I would like to welcome Ms. Pooja Sharma from Nepal to share with us a little bit about the e-cooking market development. So Ms. Pooja Sharma is the Country Director for Practical Action Nepal. Ms. Pooja.
Thank you, Jacqueline. Namaste, everyone. I always like to start my talk with very exciting data. So 98% access to electricity in Nepal, around 90% digital connectivity. But at the same time, access to clean cooking is not so well. So we have not progressed there. So when we talk about clean energy transition or just and fair transition, I always say if you look at the electricity access rate, digital connectivity, and the clean cooking, it's not just and fair. So practical action in Nepal, we thought that why not leverage this growing progress of electricity access or energy infrastructures and digital infrastructures. And we thought that, or we believe that digital innovations could be enabler to expedite the electric cooking market development. And thank you, GIZ and NDEV, for supporting us and believing in our ideas. So we focused on demand and supply, the availability of both electric cooktops and electricity supply, but also at the same time, the behavior, consumer confidence and awareness at the demand side. To tackle this, we introduced few solutions, actually various solutions, but I would like to give you a few examples how different solutions help to expedite the electric cooking market in Nepal. The first one is about business-to-business platform to connect the supply chain actors like the city-based suppliers with the communities, and with the communities and the last mile distributors who want to enter into the electric cooking business. Another one is about the consumer-facing mobile app, which actually provides practical information about various electric cooking products, the price and the quality of the products, together with demonstrations on various recipes which can be suitable for electric cooking devices, together with the electricity safety advisories and many other technical advisories. This tool has actually helped consumers to gain confidence and also encourage adoption. The next is about the management information system, because I talked about electricity supply, and electric cooking cannot be achieved without the reliable and quality electricity supply. So what we wanted to see is how can data enable the electricity providers in the rural communities. So so there are rural electricity cooperatives in Nepal who are managing and operating the distribution systems. So this management information systems actually help those electricity cooperative providers to analyze their performance and also to better plan their infrastructures. And this data, the data generated from the MIS and the self-assessment app actually contributed to the energy planning of the municipal governments as well. So our belief in the last 1.5 years has actually turned out to be very true, and we have received enormous appreciations. The most one is on the B2B platform. The private sectors are very much receptive about the platform, and they're using these platforms to sell their stoves. The interactive voice message, again, has enabled the customers or the users to better use the electric cooktops, because when you buy the electric cooktops, it's not only about buying, but about using it continuously. And you always need to have post-purchase behavior support. And different digital solutions has actually proved that these solutions can help the customers to use it. There are other things as well, like Internet of Things, which has helped to track the use of electric cooktops or the electricity use, and it has supported the use and also provided insights into the sector, so that can be used for the carbon credit program projects also. So IoT is another example of the digitalization. Looking ahead, actually, artificial intelligence can help suggest personalized recipes, forecast demand patterns for utility planning, and also even have like targeted awareness based on the socioeconomic conditions of the community. So I'm not a digital expert, but I do believe in the power of digitalization, and with the right tools, we can transform the electric cooking market in Nepal. Thank you very much.
Thanks very much, Pooja, for the perspective on technologies being deployed in Nepal. Next up, we have Mr. Nawaraj Dharma, who is the Executive Director for the Alternative Energy Promotion Center from the Government of Nepal, to show us a bit more about the government policy perspectives. Over to you, Mr. Nawar.
Good morning, everyone. Thanks to the organizers for this opportunity to share some of our work on enabling policy environment for modern energy solutions through digital innovations. Alternative Energy Promotion Center is the Government of Nepal's focal agency on renewable energy and energy efficiency under the purview of Ministry of Energy, Water Resources and Irrigation. And we have been actively fostering a supportive ecosystem for digital innovation in just energy transition, mostly in the small scale renewables and energy efficiency. And we have been following our approach a strategic and inclusive approach, focusing on 3 key pillars, namely policy integration, institutional collaboration, and technical support. Mainly in terms of policy integration, we are government's policy implementer. Basically, renewable energy subsidy policy is the main guiding document which we implement through other instruments like Renewable Energy Subsidy Delivery Mechanism, Central Renewable Energy Fund Operation Manual, and the Sustainable Energy Challenge Fund. So while implementing these policies, digital platforms are now integral part of this to streamline the application, verification, subsidy disbursement, monitoring, that kind of processes. Similarly, we have been also following the National Renewable Energy and Energy Efficiency Strategy, which guides us to work us in the energy efficiency sector through various tools and demand-side management initiatives. Likewise, we align our digital activities into Digital Nepal Framework, which is the national policy framework which guides the overall ICT solutions across the country, and our energy system solutions are also aligned towards that. Under the institutional collaboration, we basically ensure partnership with various organizations and do the capacity building. Various development partners including GIZ, ADB, UNDP, World Bank, UKAID, KFW, GCF, and other partners are the ones with whom we have been partnering. And under the capacity building, particularly we focus working with the private sector, provincial governments, local governments, and civil society organizations, so that we make them equipped with the right skills and technologies required to go digital in terms of providing energy services. We do also have the technical support initiatives, which basically ensure the cross-sector integration by working through various partners and stakeholders. Some of the examples that we have been using for the support are, for example, SCADA system we normally consider as a very high-tech advanced system for big energy infrastructures, but we have tried to introduce this for the relatively smaller systems like waste to energy, large biogas systems, mini hydro projects, mini grids. So in this kind of projects also we have introduced this system. Similarly, for the monitoring, we do remote monitoring of the renewable energy systems, so that we can monitor the systems online from the central location, but actually the systems are very remotely located, which are far away. If we need to travel to the site, sometimes it may take weeks, not only days, but we can do the monitoring online. Similarly, in some of the payments that users have to do for the local micro utility or local service provider, we have recently introduced e-payment system for tariff collection. This has been very recently piloted in one of the province, Karnali province in Nepal, but it has shown very good results, and we hope that this can be scaled up to other places. So AEPC's holistic strategy combines the robust policy and regulatory framework with strong collaboration among the partners and stakeholders, and we have demonstrated the good results through the work we have been doing. Few other examples, actually Vikas presented this morning in his presentation the work that we have been doing together with the GIZ support. The National Renewable Energy MIS system currently established and operationalized, but we aim to develop it further and expand. Similarly, the GIS-based planning tools, particularly being utilized for the municipal energy planning in collaboration with the local governments. Similarly, the modular planning tools for particular technologies. For example, there are planning tools for solar pumping system, solar rooftop, micro hydro design tool for the system design of micro hydro, those kind of things. And we have also introduced some renewable energy learning help desks and energy efficiency help desks through which even the users can interact with us and we can guide through the basics that they want to learn. So these tools are designed not only to improve the service delivery, but also to promote evidence-based planning, transparency, and robust monitoring and evaluation. So importantly, AEPC has enabled the sub-national governments, the provincial and local governments, to utilize these platforms and make sure that these are used for energy planning and implementation at the local level. Of course, we do also face challenges, few key challenges to highlight. Regulatory issues, sometimes these kind of things are quite small and quite detailed, so may not be part of the regulation all the time. So that's why when the things are voluntary or optional, then there is a chance of being faded focus on those. Inadequate institutional readiness, especially our work is focused on the remote and rural areas, so there is difficulty to really get the required institutional readiness there. Also, the human resource or skill requirements are also constrained in many instances, and we do need to make the repeated efforts for that. Similarly, the technological weaknesses. As I mentioned, we do work in the remote areas, and sometimes the technology itself is not working. Connectivity issues or the coverage issues are also there. Similarly, the budgetary limitations. Because of the small scale work, sometimes it might get low priority and budgetary issues are there. But through the work that we have been doing, we are able to demonstrate that this is worth doing. And when we talk about the resilience of the energy system, we do need to see from a small scale to large scale with the equal focus, so that then we can make sure the services are reliable, high quality, and ultimately each and every individual is served. And particularly in the context of just energy transition, leaving no one behind can be ensured through the efforts that we have been making. So AEPC's proactive adoption of digital tools demonstrate a strong commitment to modernizing Nepal's energy sector. However, to fully realize the potential of these innovations, there is a pressing need for institutional strengthening, capacity building, and sustained investment in the digital infrastructure. With these words, I stop here, and if there are any queries, I'll be happy to take during the discussion. Thank you.
Thank you very much, Mr. Nawaraj. Rounding us off for this initial opening session of session overviews is Mr. Frederick Tesfaye, who is the energy lead for GIZ in the Philippines. Frederick, please.
Good morning, everybody. So I've been asked, or I'm going to be here sharing the views, or our views at GIZ, and my personal views also on how Philippines, the look ahead here in the Philippines. And when we talk about digitalization and we talk about just transition, for me, I see it's progress. And there really is no way around progress. We heard examples, it's technological, it's technical, community-based solutions, but it's really progress in all these areas will be gains of efficiency. Gains of technology really create change within systems. And honestly, these things are being solved in engineering offices. They're at the manufacturing level, technicians in the field. We share ideas, but these things aren't solved on a panel. They're solved in the real world. And beyond these topics that we've discussed today, energy efficiency, building codes, minimum energy performance standards on all types of technologies and appliances. And a lot of the discussions were on cooling. And sitting here in Southeast Asia, especially in the Philippines, cooling is a necessity. It's not a luxury. So having these things here really will only grow. So as progress comes, demand for cooling will grow. And beyond these digital solutions, behind the meter solutions, community-based solutions, like Yusegev was already describing, which is happening here and in many countries around the world, they are very important. And yes, they do have financing as a key barrier, but also as a key catalyst that can really make a change. And I think that the liberalized market here in the Philippines is great playing ground and really testing grounds to see how this can happen in a developing, upticking economy. You have the American influence, you have European, you have Southeast Asia. Philippines is really at the center of everything that can take the best of all worlds. And also what's, I would say, very strongly considered here is also taking the interests of all parties into consideration. You have the consumers, the grid operators, power producers, technology companies, all different aspects that play a role as a whole. And in the end, it's counted with money. So that's really where a lot of these interests lie. And that's what digital solutions can bring. They have the interconnection, they create efficiencies and value within an economy, but within the energy system. So when we talk about interconnection, Philippines, it's not so easy. Talk about the ASEAN power grid, Philippines is also really trying to connect itself here. And whether it be with undersea cables or digital connectivity, there's a lot of potential that comes and a lot of progress that comes when things are connected. And looking at Germany, a lot of the technology comes here. From here, we heard also from Siemens, I think I need to be louder, the digital solutions and the technology that is coming from the European market, from the American market, in China, in Asia, India as well. There's so many things happening in the world, and Philippines is poised to take advantage of everything. I see a lot of these markets and virtual power plants and community-based virtual power plants as great testing grounds here. There's places in Austria and the US that are really taking advantage of these new technologies, AI, and ways of communicating and balancing these monies. And the flexibility is really aiding in the democratization of energy. And I think that's really one of the big changes happening, is that coming from 60 megawatts down to 5, down to 1, down to kilowatt level, these is really where energy is going to be given access to everybody. And in industry, I think that there's a lot to be had in balancing load and time and schedules towards real-time pricing and manufacturing levels to really be able to balance the demand and prices. I have one final topic which hasn't really been touched on today, and that's the human element in all this. I feel that GIZ, over the many years I've been working on capacity development, and I hear that word a lot, and it's really about doing it better, but in, I would say, all the ADB member countries, that's not an issue. I don't believe that any country or any people around the world have an issue in learning the skills and the capacity necessary. It's, I would say, really the respect. And in that, it comes with the respect that's given to the people who are installing air conditioners, installing the power grids, and that really translates to their money. Here in the Philippines, a big issue is, I would say, brain drain and skills drain, which people go to Dubai or they go to Singapore and they make much more money, and that's why they leave. Leaving Philippines, I would say, not behind, but it really gives, there's a gap there. And I think that showing the respect and giving that as a topic of value and showing to say, look, you are the ones building our nation. And in the end, that's what's going to make a change. That's where GIZ has a lot of TVET experience. I think that in many countries that is represented here, we've worked, we've done things, and beyond the energy field and beyond the energy sector as a whole, there's many different aspects of this. But GIZ here has been for 75 years in the Philippines. We're really proud to be working and supporting the DOE today in their mission, especially USEGEV and the REMB Renewable Energies, and we do look forward to many more years of cooperation. Thank you very much.
Thank you very much, Frederick. And we are now coming into the panel discussion. So I'd like to invite once again Dr. Kwong and Ms. Reena, Prasoon, Ms. Pooja, Mr. Nawaraj, as well as, of course, last but not least, Frederick, back on stage, please. Thank you, panelists. Great. We have everyone on stage. Welcome back. And I'll kick the first question off with Dr. Kwong because he's been sitting there in silence for a while everyone else presented. So I wanted to come back to the question on some of the global examples with digital demand responses on appliances and the application of these demand response appliances and how it's supported grid resilience and improved strengthen grid operations through this deployment of demand response appliances. Thank you.
Thank you for the question. So, some keyword we are discussing now is the demand response, grid resilient, microgrid, digital grid. And just let me share with you our project we do for Malaysia for consulting service. Also topic about the demand side response. And let's say when you the penetration level of renewable energy integrate in your grid, not only so then the grid resilience is we talk about not only system stability but also is system flexibility. And we have many solutions for enhance the system stability, like you have new technology like battery storage, right? And you have the synchronous condenser, something. But moving to the system flexibility, yeah, demand response is one of the most one of the best solution, yeah. And to have the most suitable demand response, for sure we come back to digital world. So how we can build up the digital twin of your distribution network. From that you can, let's say, view detail, okay, where is the weak point, everything in your grid. From that, then you can have planning. So that's why we go up to it, Meranco, to build up this one first, as one the step to increase the efficiency of demand response. Yeah.
Thanks very much, Dr. Gong. I'll come to Prasoon next and really think through, what are some of the key enablers. We've looked at the technology from a systems-wide approach, and now just thinking through the enabling environment as well as a systems-wide approach. What are some of the enablers from a technology standpoint do you think Prasoon would be crucial to help make these deployments successful?
Yes. Jacqueline, I'll likely answer slightly tangentially, but I think that would help everyone better understand the enablers. So if you are talking about demand response in cooling solutions, the general discussion has been around room air conditioners. But in our research, what we have found is the small commercial cooling solutions. In India, we call them light commercial air conditioners, or the likes of VRFs. These are slightly bigger solutions, and what we have noticed is that these solutions are already IoT enabled. What that means is, in the first wave of demand response ready ACs, probably we need to target these solutions, and then maybe we go on to the larger room air conditioners market. I would extend the same analogy to the chillers, which are being used in buildings. You would see a lot of building management systems already allow chillers to be remotely controlled. Now, it's just a matter of another layer of software integration that has to be done, essentially to automate their response to grid. So these are the certain early steps that could be taken to maybe pilot and execute some early DR programs. And based on those learnings and adoption, we can go on to increase them further towards the room air conditioners.
Great, thank you very much. And now for Ms. Reena, thinking through, some of the scaling potential, we've heard some of the innovations that are needed. Can you speak to what are some of the opportunities in the South Asian market for scaling potential for deployment of some of these innovative solutions? Thank you.
Thank you so much for the question. I'd like to start by talking about two things. One, I'd like to reiterate Dr. Christina's point on the digital innovation for just energy transition and demand response is possible with the right policy, strategy, and technology. And when we talk about the demand response, one of the audience member had raised a point on for the demand response technology costs that that the utility or the system operator has to bear versus the peak load days, which are maybe close to 30 in a year. So how is it justified? So we have to look at a variety of technology options which will not only help them support the peak during this transition time, but also will help them utilize this technology to further manage the overall systems. So in India, like we talk about cooling or cooling actions and stuff. So there are many programs in the government of India has taken up for bringing efficiency. There has been a huge shift towards from the regular lights to LED lights, which has been successful. There is India Cooling Action Plan, which I'm sure there's a lot to learn for our friends from Asia. And but I'd like to emphasize more around the point. Another question which has been raised in the WUA app is will DR what happens with this demand response technologies during thunderstorm time or at the time when the peak is not that high? So can DR help in managing that during those situations also? So I would say that DR can also be utilized to manage load shifting at the time, and use with the IoT-enabled devices, use that time when there is more demand and sorry, more supply and less demand, to utilize with the sensors that energy to maybe charge the battery. So battery energy storage system, which also there's a huge push, is going to play a key role here. And another technology, just one last point, another technology which with the huge shift from regular mobility to green mobility, we see that there are scope for vehicle to grid also, grids providing support and flexibility that the grid will require in the just energy transition with so much of renewable also pumping in energy. So can they be helping in the peak demand and reducing the load at the time when when the grid needs it? By supplying back the power. So we have done a pilot around experimenting with vehicle to grid, where the vehicle connected to the grid to supply back at the signal from the from the grid operator. So those are the different digital innovations that we are looking for the support that we need going forward with the net zero transition we're looking at. Thank you.
Great, thank you very much. Thanks for the overview and providing a segue on the policy perspective. I want to invite Mr. Nawaraj next to also share a bit more of a view on the role of technology and the ability, and in fact this is one of the questions that also came through online, the ability of leveraging technology to provide digital justice, and how policymakers are leveraging the digitalization process. For example, you mentioned earlier the Sustainable Energy Challenge Fund. So are there any specific examples through these applications where the technology utilization has enabled just transition access for wider populations? Mr. Nawaraj, thank you.
Thank you. Actually, this digitalization, as we discussed, and as I mentioned earlier, we need to consider it for entire range of technologies when we talk about the energy services, and particularly in the context of just energy transition, where, for example, for the people who are living in the remote and rural setting, in terms of energy demand, it may be low, but the basic services need to be done through the modern energy solutions. So in that case, we need to make use of the technology so that the service is ensured in a right way, and reliability is also ensured. And while getting the services through the micro utility or whatever, or even in the household scale, the use of technology really helps. You sort of wanted me to explain a bit on the Sustainable Energy Challenge Fund. Sustainable Energy Challenge Fund is a viability gap funding based mechanism where we support projects which are developed by the private sector, which are mostly small scale projects. In terms of size, these are all below 1 megawatt in terms of installed capacity. And it can be electrical, it can be non-electrical, all kinds of energy technologies. And there, the technology has really helped. For example, we have open application system, and all the processes are made available through website. Anyone who is interested can go through and then apply, and there is different stages of application. First stage, we receive the concept notes, and based on the shortlisting of concept note, full proposal comes. And once the project is selected and goes into implementation also, there is a use of technology again. So the digitalization has helped the process itself in terms of getting such projects implemented, as well as getting the services from such projects to the end users. So this is how this has really helped. Another very important side of the digitalization that we have been following is we are working very closely with the sub-national governments, provincial and local governments. Actually, in the Nepalese context, this is a bit new also. We had a new constitution in 2015, which federalized the country. And after the new constitution went into implementation, the rules have been shifted from the federal government to the provincial and local government. So they have additional responsibilities to take on in all sectors and in energy sector as well. So in that case, in overall planning, implementation, monitoring of the energy activities through provincial and local governments, we have been working closely with them and supporting so that their service delivery is rightly executed at the provincial and local level. Thank you.
Great, thank you very much. That's a really good perspective on the broader deployment in Nepal. I want to go to Ms. Pooja next for a bit more of a specific view on e-cooking deployment and the digitalization and your past experience in deployment of the projects that you have in Nepal on e-cooking. And then while you're at it, one question came through on your thoughts on updating labeling schemes for e-cook stoves as well. Please, over to you, Ms. Pooja.
Thank you, Jacqueline. So first, let me take a question on e-cooking market, where like electric cooking target is already included in our NDC. So that way it's already prioritized in the country. But in the term of uptake of electric cooking, there are opportunities, but also few challenges where organizations like us are working. For example, especially in the demand stimulation and market development, where private sector's role is crucial. So on the demand stimulation, especially, the digitalization plays a very important role. As I mentioned before, like there are various apps like consumer apps and then IVR technologies which can help customers to understand better about the electric cooking technologies. But there are also other things which I was actually thinking, and if you may allow, like I want to relate it to the demand response as well, because everyone is talking about demand response on other technologies and products. So I was thinking, like, if what happens if demand responsive electric cooking products are available in the market? Are we really going to solve the problem of women that we are thinking? Because when you talk about demand response, it may require shifting to other alternatives, and I fear that people who are cooking on electric cooktop at the moment might go back to the traditional cook stove as well. So whenever you talk about demand response, yes, it's good for the utilities, yes, it's good for the smart applications of the smart people. But if you are talking about people living in the very rural communities who are using traditional cook stoves, then demand response on electric cooking is actually a viable solution or a smart solution. It is or not, I don't know. So we are thinking in that line, but I don't think anyone has an answer at the moment. But I've seen few researchers are there. So just wanted to talk upon that point also, because I was very tempted to talk about this point. And then on the labeling, I think on the labeling, Navraj sir is the most right and appropriate person to talk about, but we do have standards, and we do have standards for the cook stove, and they're like the kind of cook stoves or the electric cooktop which we are promoting or encouraging are all quality assured, and they need to meet the quality standards of the Renewable Energy Testing Center, which is in Nepal. But on the labeling, I'll pass this question to Navrajji.
Thank you. Let me briefly add to this conversation. Actually, on standards and labeling, particularly for national standards, we have national standard body which is responsible to look after all those standards, which is under Ministry of Industry, but we are very closely collaborating with them to develop the standards, both for biomass-based improved cook stoves and electric cook stoves. And those standards for the electric cook stoves, the induction and infrared and electric pressure cooker are already out, already implemented. For the biomass-based cook stoves, the national standard body suggested that we first start with the sectoral standard, which is a kind of benchmark, not at a national standard. We continue implementation of that, and after a certain time, we can transition to the national standard. So accordingly, we have been doing that. And the National Testing Centers he mentioned is a sort of mandated body who does the testing and certification of all the devices based on the standards that we develop, be it a sector standard or be it a national standard. And they solely based on that, they develop the testing protocols and test and certify. This is how the system is working. Thank you.
Jacqueline, just, one point, because sorry, Jacqueline. Yeah, so one last sentence, that since we are talking about just and fair energy transition, we should not forget about like the loss of livelihoods, right? So we've been talking in various sessions about loss of livelihoods during this transition. What about loss of livelihoods like in the journey of digitalization? So there were many people who were doing, like social mobilization, community engagement, doing a lot of awareness projects, awareness activities. So in this journey of digitalization, we should not forget again about the people who were already, not into the digitalization process, and also we should think about reskilling and upskilling of those people, those market actors who were not into the digitalization process before. So, we talk a lot during other technologies, but again, in digitalization also, we should not forget this.
I just wanted to reflect on the challenge posed by Pooja ma'am. So while this is a problem, this in some ways is also an opportunity. With electric cooking, you are potentially looking at automation of cooking, and probably you need not cook at a time when everybody is cooking. You can probably shift loads, you can do all the prep. You can program it in a way that it boils your water 5 a.m. in the morning instead of 8 a.m. and probably you need to reheat a bit later. So it is a dual opportunity. It's a problem as well as a potential solution as well. Talking about maps for electric cooking, I would like to share certain recent learnings from India. So India has had a voluntary labeling program for induction hobs for the past few years. A recent policy analysis conducted by us seemed to suggest that while the program exists, there wasn't probably much participation from the market or manufacturers. So very recently, there was a stakeholder consensus built among the manufacturers that probably the program need to be revised. The performance standards need to be slightly reduced so that manufacturers are able to meet that MAPS. But the good thing is that they have also agreed that the program can be made mandatory. That essentially means that any product which is not certified and does not meet the MAPS is not allowed to be sold in the market. So that's something that is about to happen soon.
Thanks very much. That was clearly a very question that was very intriguing for many panelists. I want to come to financing next and invite Frederick to talk about this topic. And when we look at digitalization, in many ways it's seen as a tool, and in designing and implementing projects is also seen as a very important lever to support perhaps monitoring and verification processes. So I want to invite Frederick to talk a little bit about how digitalization and the deployment of it, how does that help some of the projects better access financing, and how does that help the implementation of the project and the MRV process as well? Thank you.
Okay, thank you. Very complex topic in general, but when we talk about financing, the main element is risk assessment, risk analysis, and when risk does come into play. When we do digitalization, we create a good basis of data. So this can be used to be able to reduce the risk, be able to analyze it, be able to convince the people that have the capital to invest in it. New technologies are always more difficult, and this is where financing comes in with the likes of Siemens or Audi or whatever big energy companies they are. They have their own capital to deploy, makes it more easy. But imagine the amount of time that this takes to invest $15 billion. Takes a lot of brain power and a lot of thinking of power and a lot of preparation, a lot of changes. So when we look at it from that perspective and we take it at levels down, manufacturers of air conditioning appliances or cook stoves, to get that financing is not easy. It is really difficult. And when you do that financing, you invest in your factory line today, your technology changes in a year and a half and you have to reinvest. So it's a very volatile market, and progress in innovation changes on a daily basis. So where, when, and how to invest is something that is a very great, I would say, care to be taken and invested. And when we talk about MRV, I see, at least from GIZ perspective, on a government side, MRV is about what conditions are being met within a nation as a whole. And so even beyond a nation, we have the ASEAN grid. There's a lot of work being done, and Philippines is one of the leaders on the harmonization of different appliances, different electronics. That will then also ease, because then your market grows. So beyond just one country to sell your product, you now have the entire ASEAN grid. So there's different aspects that needs to be taken and looked at, and it's far too complex to be answered while the light is blinking. Time is up. But yeah, thank you so much. I hope I answered it, and I'd like you to come in, please.
So as the Siemens, we can help you to answer when and how. Yeah. I can say with you that we are conducting the project with UNOPS, yeah, to help to build up the roadmap for Indonesia, how to integrate the battery storage in their system. That's one example. How and so on. Yeah.
Thank you very much. And with that, I won't wrap up. I think all of the panelists spoke very, very clearly what the opinions are. I think the financing and the leveraging of technology is really crucial. So really happy to have been able to cover that in the context of all of us sitting here in the Asian Development Bank. Hint, hint. But with that, let me hand back over to Dr. Narayan for closing remarks. And thank you all very much to the distinguished panelists for this session. Thank you.
Thank you, Jacqueline, and thank you all the panelists. Really, really nice conversation. So I wish we would have a bit more time so that we could have that one, but everywhere is the limitation, so that we have to respect. So I don't have that much to say. Just thank you, Jacqueline, and thank you all the panelists, and also the big thanks to Dr. Govera, Undersecretary, DOE Philippines, for coming to us and staying forward all the time and inspiring us to have the good discussion. That was really, really highly appreciated. And very, very big thanks to ADB for providing us the opportunity to be here together, bringing all of you together. So that was really nice opportunity. And the CLASP, which Jacqueline represents, and the AEPC Nepal, Smart Grid India, Rina represents, Siemens, Hitachi Energy, and all GIZ colleagues who basically participated, contributed to the earlier session and this session as well. So, and all these dignitaries and the the representative from the government, development partners, civil society organizations, the NGOs, and all the participants that really without you, we could not be able to have the discussion and also this wonderful the session that we had. Just before closing, I have one question for you to bring back together with you, and I will bring Nepal's example. So just maybe the similar also you can also relate to your own countries. The existing, the fuel, the energy supply situation, please think of. And then how we can have the just energy transition that we need to move. It's the energy transition that we talked a lot. It's not just the technological or some financial solution. It consists of the whole range of including human. So how we can have that one. So basically in many developing countries, the energy consumption pattern is dominated by either by the biomass, solid biomass, or also the fossil fuel. So how it can be possible that in that situation, how we can bring to the next level just energy transition. I will bring just one example, Nepal's current energy consumption pattern. The biomass, largely for household cooking, it's 55 to 60%. And fossil fuel, including the petroleum and coal, it is 25 to 30%. And then electricity, including off-grid, on-grid and off-grid, is 7 to 10%. Now we are saying that the transition to the clean energy, and it's just transition that we are talking about. We should reduce the greenhouse gas emission. It should be just, it should be fair, it should be inclusive. So how 7 to 10% the electricity pie in the pie, then the 55, 60% plus the fossil fuel, how we can transit that one? So how it is possible? It's the question. So I don't have the answers. From country to country, the answers might be different, but that is what basically we are facing the biggest challenge. Finance, technological, and other things comes later anyway. So that is where we need to also look at, and we need to start with this. Thank you once again. And there is one saying: the hungry man is angry man. So that should not be, because it's the launch is there, and we are taking much of your time, and sorry for that. So anyway, thank you once again. So the last, maybe the group photo.